Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about microprocessor, microcontroller and interfacing techniques. We're going to start video lecture for this particular subject, and the subject code is 21ECC301P, right? And in this video we're going to see introduction about microprocessor, microcontroller. We will see the overview of the syllabus. More importantly, we will see about why is that you ought to study this particular subject, right? And we will see some basic terms about microprocessor and microcontroller, right? To start with, why is that you ought to study this particular subject? Like being an electronics and communication engineer, it is very important that you should have some basic knowledge about microprocessor and microcontroller. That is the very primary objective, right? And with that, what is the career opportunity it provides, right? You can have hell a lot of opportunities in this particular field. That's because if you take microcontroller, you will have a lot of applications regarding microcontroller. Microcontroller is used in almost in all electronic gadgets right now. It may be your mobile phones or any electronic devices. Even microprocessor, in all computers you have microprocessor, right? So that is why as an electronics and communication engineer, it's very important you should learn about this particular subject, right? And for an example, if you take microcontroller, right, you have 8-bit microcontroller, you have 16-bit controller, you have 32-bit controller. Depending upon these bits, lot of applications. Say for example, starting from a small toys like a battery devices, a small device, a small battery device that is used in some toys or very limited application, right? Very basic application. You will have microcontroller, right? It will be an 8-bit controller where it will consume only less power. And if you take 16-bit microcontroller, we can use it for industrial automation applications, right? So it will consume more power when compared to the 8-bit, and it is more powerful than the 8-bit as well. You have a lot of applications in industrial areas and automations, all those things. And more importantly, 32-bit controller, right? It can be used in sophisticated applications like medical applications and military applications like that. So any gadgets if you take, you'll have microcontroller, right? So it is very important that you should learn about microcontroller and microprocessor. And apart from it, career wise, you can develop your career as a chip designer, as an embedded designer. You have a lot of opportunities there. And moreover, India is right now planning to develop semiconductor industry, semiconductor technology, right? We're going to boom semiconductor technology, and India is going to be a hub for semiconductor technology. Like we have partnered with a lot of foreign countries like Taiwan, etc. Right? So it will be a great opportunity for you people to concentrate in this particular area, and that is why you study this particular subject, right? And coming to overview of the syllabus, we will see about the syllabus. To be frank, we have to start with microprocessor, but this syllabus is like a practical course for you where you have to study about microprocessor, microcontroller, interfacing, what are the applications, and more importantly, you have to do some projects based upon what you have learned. So this particular syllabus is designed in such a way that more importance is given to microcontroller than microprocessor, right? So you will concentrate mostly about microcontrollers, and you will study in one unit about 86 processor as well, right? And as I said, it's a practical course. It's very important that you have to do some project using microcontrollers, right? Using a microcontroller or any controller, you have to do some project at the end of this course, right? And coming to unit 1, you will study about basic information about 8051 microcontroller, where you will study about pin diagram, architecture, instruction sets, right? Addressing modes of 8051. And unit 2, it's all about peripheral programming in 8051. You will study about various programming and interfacing of DAC, ADC in unit 2. And unit 3 is very important, where you will study about Atmega controller, what is the architecture, pin diagrams, right? How the interfacing works. It will help you in perspective of your project, right? And unit 4, you'll study about microprocessor 8086 processor. Once again, the architecture, pin diagram, instruction set, and all those things. And unit 5, you'll study about microprocessor interfacing, right? So this is the overview of the syllabus, and we will start with basics of microprocessor. What is microprocessor first of all, right? So we'll see what is microprocessor, microcontroller, and then we will see the difference between microprocessor and microcontroller, right? So if you take microprocessor, we can say it as a small device, a digital device, right? That is used in almost all the computers. Every computer will have processor, right? And the main foremost task of a processor is it will perform arithmetic and logical operation. So all the arithmetic logical operation which is done by the computer is done by microprocessor, right? And very importantly, we can say that microprocessor is specifically designed for a general purpose, right? So, and importantly, microprocessor, you will not have memory, right? You will not have inbuilt memory. You will not have input output ports, right? You will not have any hardware chips combined to it, right? All we have to do is we have to externally connect it, right? We have to externally connect memory. We have to externally connect input output devices, peripheral boards, and all those things, right? That is the main difference between microprocessor and microcontroller, right? So whatever I said right now that is given here, you can see microprocessor is an important part of computer architecture, without which will not be able to perform any operations in your computer. It is a programmable device to perform arithmetic and logical operations, as I said. And you have to connect externally the memory, peripheral, system bus, everything, right? And when it comes to microcontroller, it's like a small computer, right? It is an integrated circuit where you will have inbuilt memory, input output devices, everything will be in a single chip, right? And as I said, microcontrollers will be used in almost all devices, right? From small battery operated devices to military applications. In all the consumer electronics, we will use microcontrollers, right? And as I said, you can see here, microcontroller will not only be a processing unit, it will have memory, few IO ports, timer, everything will be inbuilt in, right? You can see the technical difference here. This is the microcontroller, where you can see it has CPU, RAM, ROM, input output port, timer, serial port, everything is integrated here, right? So that is in a one chip, right? This is about microcontroller. It can be called as a smaller computer, right? And these are famous microcontrollers of different companies: Motorola, Intel, Ziglag, right? And PIC. And what is microprocessor? As I said before, it is for general purpose, and you can see the CPU, right, the microprocessor. And apart from that, you will not have anything. Everything has to be connected externally. You can see ROM, RAM, and IO port, timer, serial port, everything has to be connected externally, right? And that is the basic difference between microprocessor and microcontroller, right? And with this, you can add few more points, like if in terms of microprocessor, everything is connected externally, so it will be a complex circuit. But microprocessor, it is a very compact, it is very simple design, right? You can see the difference between microprocessor and microcontroller, where microprocessor is the heart of the computer system, microcontroller is the heart of the embedded system, right? And microprocessor, where memory and IO component, everything has to be connected externally. Here, everything will be connected internally, right? The circuit is complex because it has a lot of external connection in microprocessor, but in microcontroller, everything will be in a single chip, right? So the circuit is less complex, and we have already discussed this particular point: memory and IO components connected externally, right? And it's a very compact system, right? That is, microprocessor cannot be a compact system because we connect everything externally, so that it will not be a compact one. But microcontroller, it is a single chip, so it is a compact system, right? And microprocessor are not efficient as like microcontroller, right? And apart from it, the technical difference is microprocessor have zero status flag, where microcontroller will not have zero status flag. What is zero status flag here? Obviously, microprocessor should have zero status flag because it performs arithmetic logical operation. So if the result of any arithmetic operation is 0, then it has to enable that particular flag, 0 status flag. But in microcontroller, you will not have 0 status flag, right? And microprocessor has less number of registers, where microcontroller will have more number of registers. And you can see microprocessor is predominantly used in personal computers. But microcontroller, it will be used in almost all electronic gadgets, like washing machine, air conditioners, microwave oven, everything, right? So this is the basic difference between microprocessor and microcontroller, right? And apart from it, you have to know about some basic terms about microprocessor, microcontroller. The very important thing is Van Neumann architecture, which we can also call as Princeton architecture, right? This architecture, there is two famous architectures. There is Von Neumann and as well as hardware architecture. The only difference here is in Von Neumann, you will have single memory, right, where it will have single memory for program and as well as data, right? But in hardware architecture, you will have separate memory for program and data, right? That is hardware architecture, right? And apart from it, when it comes to processor, right, you have CISC processor, that is complex instruction set processor, where it will have that supports many number of machine language instruction. It is a complex one actually, right? But predominantly we use RISC processor, which is reduced instruction set processor, right? Where it will have small number of machine language instructions, right? So RISC processor expected to execute program faster than CISC because it is simpler, right? And apart from it, in microcontroller, you would have started your lab exercises and you would have started your simple addition, subtraction programs, right? Whatever you type for microcontroller, right, you will type some instructions, correct? ADD, MOV, add, move, all those instructions you give, right? So all those instructions, processor will not understand all those instructions, to be frank. Those instructions are called mnemonics actually, right? That mnemonics, when you type and hit enter, you can see some numbers, 0E, 0A, something like that displayed on your board, right? Where that is the one which will understood by the microcontroller or microprocessor, right? That is opcode. For every instruction, it will have its own opcode, right? So to feed the information to the microcontroller or microprocessor, you have different languages, okay? First thing is high level language. What is high level language? You would have come across this particular term. High level language is like a computer programming without the knowledge of processor, right? Writing program with high language like basic, Fortran, C, all those things. That is called high level language. And what is assembly language programs? Assembly language programs are something like mnemonics. That's the instruction sets, right? Add, move, whatever instruction which we type. That is assembly language. But even assembly language is not understood by microprocessor or microcontroller, right? That is what said here, a programming language written in mnemonics, right? And assembly language programming is microprocessor specific. It cannot be easily understood like high level language program, but that is easier than machine language program, right? And what is machine language program? You can see this machine language program is the one which is understood by the processor. So whatever instruction which you give, it will convert that to a machine language program, right? So machine language program is a binary code program that are specific to the processor that can be directly executed by the processor. The machine language is the lowest level program and cannot be easily understood, right? We will not be able to understood, but microprocessor or controller can be able to understand only the machine language program. So there should be some converter. We should have some assembler, compiler or interpreter to convert whatever instruction which we give, right? We have to convert that information into a machine level language that is understood by the controller or the processor, right? So that is why we go for assembler. What is assembler? Assembler is an application program that converts assembly language program into a machine language. You now understand what is assembly language and what is machine language program, correct? And similarly, there is something called compiler. Compiler is the one which converts high level program, right? That is written in C, basic, Fortran, that converts into machine language program. We can use compiler. And there is something called interpreter. Interpreter is one which can convert both high level language and as well as the assembly language program into a machine language program, right? Only basic difference is interpreter can decode the program line by line, that is one line at a time, right? But compiler assembler can function only in the entire program, right? So now you understand what is the basic difference between microprocessor and microcontroller, and we have seen what is one human architecture, what is hardware architecture, what are the other basic terms, what is assembler, what is compiler, and what is interpreter, right? And very importantly, you should come across this particular information, that is buses. If you take any microprocessor based system, you will have these three buses: data bus, address bus, and control bus, right? And from the name itself, you can understand data bus is specifically designed to carry data from the peripherals to the CPU or vice versa, right? For input output device to the CPU or from CPU to the other peripherals. Okay, and similarly, address bus carries specified location, memory locations to CPU or the peripherals, and control bus carries control signals which is used for coordination purpose, right? So, and apart from it, this is the diagram which speaks about one human and hardware architecture. Actually, this is a bit wrong, so it should come like this. So it's CPU. This entire thing is CPU, right? So you can see the difference between von Neumann and hardware architecture. So von Neumann can also be called as Princeton architecture, right? Where you have CPU and you have single memory which has both program and as well as data, right? And here you can see the hardware architecture. You have separate memory for program and separate memory for data, right? What is program? Right, the instruction which we give, right? Whatever instruction which we give, that will be saved in the program memory, and the data, right? The data, the operand which is used to execute that instruction, that will be saved in the data memory, correct? So what is the basic difference here, right? Apart from this memory, still, even though here it has separate memory, still we use one Neumann architecture predominantly. That's because single memory is shared for both code and as well as data, right? Here we have separated, and also it requires two clock cycles. That is, one clock cycle to fetch the code and another clock cycle to fetch the data. But in hardware architecture, you need only one clock cycle. But this design is considered as very simple when compared to hardware, right? And because of that, and also this is higher speed, right? Because the time it takes only lesser time, right? So it's high speed and less time because of single memory, right? But here it is slower in speed and more time consuming, and this simpler design and complex in design, hardware architecture. This is the basic difference between von Neumann architecture and hardware architecture, right? So, and you can see coming to microcontrollers, these are the types of microcontrollers where I said about 8, 16, 32-bit. When it say 8, it consumes less power. 16, it consumes more power compared to 8, and 32-bit is more powerful. It is used in high-end applications, right? And when it comes to memory or devices, we can have embedded memory or external memory. And it can be RISC microcontroller or a CISC microcontroller. We can use hardwired or Princeton architecture as well. And it can be of IC chip or VHDL format. And these are the different companies, the families that provides microcontroller, right? So today what we have seen is, we have seen basics about microprocessor and microcontroller. I have just given what is microprocessor and microcontroller. I have just explained what are the career opportunities you have. I believe this video will be very useful for you. Thank you, my dear students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும் நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.